Hello everybody and welcome to my channel. This is of course Skippy4769 or Skippy. Today we're going to be doing a programming introduction, and this is a general programming guide, but I am going to be using Visual Basic console syntax to help people understand and give a visual on what's going on. This tutorial, this instruction, this introduction per se, is specifically built so that it can be used in general for most programming languages. And I say most because each programming language has different syntax, different keywords, different definitions for different things. But we are going to go ahead and start, because with today's discussion we are going to be discussing what a program really is, steps to design a program, basic functions of a program, variables, input, prompting, processing, and output. These are going to be the topics in which we are going to discuss in this tutorial. What a program really is. It is to provide a computer or other machine with a coded instructions for the automatic performance of a particular task. And that was defined by Google. That's what I looked up whenever I typed in define program. And it makes a lot of sense, but to paraphrase it, I've basically put a series of inputs that get processed to create a desired output automatically. And for example, you got Microsoft Word. An input would be whatever you type on the keystroke, and the output would be displayed on the page in which you are working on. Operating systems, there's lots of inputs from like the keyboard. There's an input from the mouse. You can move the mouse around. There's inputs from other devices such as microphones, and the output is mostly the screen in which you are working on, the monitor, and it displays the mouse movement. If I move the mouse, which is the input, it'll display the mouse moving around the screen, and that's the output. Internet Explorer, Google Chrome, Mozilla Firefox, those are all programs. These are all just examples, of course. With Internet Explorer, Google Chrome, these web browsers per se, if used to do an input on the URL bar and type in an address like www.google.com, then it will send, it'll start the process of sending out the information and then coming back with the information, and then it's going to output the web page for Google Chrome, or Google, I should say. Now, steps in designing a program is to, for one, design the program. You want to utilize flowcharts, which I'll show you an example one here soon, and you'd also want to do pseudocode. Pseudocode is basically like an outline. If you've ever written an outline before, it's pretty much where you just write your code without syntax. And syntax is a form of basically laws or rules within the programming language in which you have to type in order for it to actually know what you are trying to accomplish. And that's all it is. Syntax is basically rules for that programming language. But whenever you go to design a program using pseudocode, pseudocode is something that you can write on a piece of paper. You can write it in Microsoft Word. You can write it on Notepad. It has no syntax, and the whole purpose of writing that is to get the logical operations done. That way you can find out if you've got a problem or anything like that. Plus, if you've already got it written out in pseudocode, all you have to do is just transcribe that into the syntax of the desired language in which you wish to create the program in. You then would want to write the code. And like I said before, you design it in pseudocode or flowcharts or an outline, whatever you desire. You then want to write the code into that desired language. Like for Java, you'll want to write it in a class folder. For Visual Basic Console, you'll want to write it inside of a module. You want to do it, you want to use syntax, basically the rules of the language. And of course, the next step is to correct syntax errors. And like I said before, if you mistype a word, like if you mistype the word display whenever you want to display something, it will not display it because you've mistyped it. And then after that, you'll want to test the executable code. If you do not correct syntax errors, you cannot execute the file. But if you do correct all the syntax errors, you can test the executable file. You can run the program. And the whole reason why you want to test the program is to see if it actually works, because most things like Visual Basic or Eclipse for Java, those are programs in which can detect syntax errors, and it will tell you exactly where those syntax errors are. But if you get the syntax errors all fixed up, you can run the code. But there's still a problem. You might have logical errors. That's why you'd want to debug the code. You want to find all the logical errors within the code and see if there's anything missing, anything wrong, then you can add it to it. And then after you debug the code, you go back up to designing the program again. And like I said before, designing a program can use flowcharts. It's probably my favorite because very easy to read. Each flowchart symbol represents something. Like the rectangles right here are basically a process. You're setting a variable sum equal to 0, and we'll talk about variables later. And then you got yourself a decision structure right here, which is a diamond. Whether or not, if count is an even number, it's either going to be true or false, and it'll continue on through there. And of course you got an output, which is supposed to be a parallelogram, but in this image it is another rectangle. Inputs are also a parallelogram. And after you design the program and you go back and you fix the logical errors, like for instance, if you meant to make count equal to 2, then you would want to change that. And that's a logical error. Your program will still run with count equal to 1, but because there's no syntax errors. But if there's a logical error, then it might make the program run differently than what you desire. And then after you write the program, or design the program, you would want to write the code. The code, for instance, this right here is just some code. Now, when you are designing a program, you'll want to understand the task that the program is to perform. That is crucial. If you don't understand what the task is that you want the program to perform, you're going to be running around in circles, and you don't want that. You'd also want to determine the steps that must be taken to perform the task. So let's say we're going to make a program to calculate how many apples a day you eat. Okay, if I eat 1 apple a day, I'll say, hey, I want 1 apple. I type it in, 1 apple today, and then tomorrow I eat 2 apples, and then the next day I eat 3 apples, and the next day I eat 1 apple. And the program is to tell us how many apples on average we eat a day. So we understand what the task the program is to perform. But to determine the steps that must be taken to perform the task is a different story. What you do is you gather input from the user. How many apples did you eat today? Well, 1. Okay, the next day, how many apples did you eat today? 2. And you go on and on and on until you get to the point where it's like, okay, we're ready to process this information. Now, all we have to do is add up all of the apples that we've eaten, and then we divide it by however many days we used it. Like, let's say we did it for a week. We add up all the apples that we've eaten, you divide it by 7, and that'll equal whatever number the average is. And then it'll display it. So that's determining the steps. And then you'll also want to utilize pseudocode and flowcharts for this. Very hugely useful tips or hugely useful utilities to actually create your logic whenever it comes to programming. Basic functions of a program. The first one is input. Input is basically anything that you put into the program. You have processing, which processes the information in which the input was received, or information in which the input was received from the user or the computer or from whatever was entered before the program was even created or after it was created. Then you have output. So you have input, process, and output. Processing can also be known as a function, but basically you got the input, then it does a function or processing, get some calculations, do if-then statements, do loops, do a timer, whatever you want to do, and then it does an output, the function value. Basically what the conclusion is to what you want to accomplish. And then it will display it. It will move an RC car 50 feet if you want it to move 50 feet. It'll do whatever you want it to do. And we're going to do go a little bit more in depth with input. Input is basically to place data into the program. Typed from a keyboard, recorded from their video or voice, a sensor of sorts like the laser from a mouse. And like I gave that example earlier, you move the mouse and then that's an input. And then types of input to be stored, you're going to be looking at strings or strings of characters, which are also called string. Basically like the word string, it's a string of characters. My name, Skippy, is a string of characters. That's input that can be stored inside of a program. Characters are individual characters like Y, T, V, S, W, and A. That's pretty simple. Integers are whole numbers. 1, 2, 3, 452, negative 99, 0, and negative 2. Those are examples. Whole numbers of any sort, whether it be positive or negative or 0, are considered integers. Real numbers, or double in most languages, are a number with a fractional value, such as 1.456, or pi, which is 3.14, negative 4.28, 0.3, 7.0, even just a whole number like 7.0 is still 7, but it can still be stored as a real number. Integers can be stored as real numbers cannot be stored as integers. And where does the input data store? It's easy. Variables. Variables are an element, feature, or factor that is liable to vary or change. That's what Google states that variables are. I consider variables a storage location in memory that is represented by a name. Very simple. But both are true. Variables do end up changing unless you have a constant. Unless if you give an opportunity to change, it will change. But yeah, all it is a storage location in memory that is represented by a name. And variables do have rules, but they're typically declared and assigned a value. You declare a name. An example. Name is the variable. The variable is the word name on this screen, right here. And it equals Tom. So whenever we use the word name, we're really meaning the word Tom. And Tom is stored in this variable name. For an example, if you're going to display this, whatever the user puts in for name, it'll say nice to meet you, and then you add the variable. So the output is going to look like this: nice to meet you, Tom. So the reason why you'd want to do this with a variable instead of just straight up putting Tom is because whenever you put whenever you ask the user, hey, enter a name, well, whatever they enter on the keyboard, where are you going to store it? And how are you going to bring it back up later? It's easy. Use a variable. It stores it into the variable called name, so then whenever you type it out, you can say nice to meet you, and then plus name. Plus is adding the variable to the end of this string right here. String is within these quotes. But it adds it to the end of to whatever you want to add it to. So anytime that this right here shows up in the program, it's going to output or display whatever that variable represents, which in this case is Tom. So it's nice to meet you, Tom. Now the rules for variables are very, very simple. You'd want to specify the data type. Data types are integers, integers which are whole numbers. You got the reals, which are doubles, which are fractional values. You've got strings, characters, and you even got Boolean, which are basically true or false. But those are the data types. But whenever you're putting a variable inside of a program, you want to specify what type of data type that variable is. In this case up here, can you guess what this data type is for name? Yes, it is going to be a string, because we do have a string of letters right here that it represents. So it's a string. The variable must be one word. I can almost guarantee you in all programs the variable must be one word. If you have two words, like if you want to say top hat or first problem, all you got to do is do what's called the camelback, or whatever they want to call it, is where the first letter of the word is lowercase, but whenever you go to the second word, you put the words together and have the first letter uppercase. So whenever you're saying something like first problem, first is all lowercase, put together with problem, but P in problem is uppercase. And punctuation characters cannot be used in most languages. Some languages do allow specific type of punctuation characters or symbols. Create the name to represent the function of the name. Basically like what we did up here. We named it name. Another example is, if you want to declare how many apples is the person eating a day, you would want to name that variable apples. That way you know that that's what that variable is representing. The variable is representing apples a day. So you type in apples a day. All one word, and if you wanted to capitalize the first letter, the second word, and third word, you can. But apples a day is going to be our variable. And whenever they put that number in there, that variable is declared as the data type of integer. So that you put integers inside of that variable. And then the first character cannot be a number in most languages. Some languages may allow it. And now we can talk about the data types. Types of input to be stored, which are data types. You got the string of characters, string. It's a string data type. You got characters, integers, real numbers, and Boolean. Boolean is true or false. Very simple. We discussed this a little bit earlier. So now we're going to go on from input to processing, where everything comes together inside of programming. It's to perform a series of functions in order to change or preserve events. An example, sum, which is the variable of what the total is going to be for this process, which is going to be 2 plus 2. That's a mathematical process. That's all it is. Typical functions, mathematical if then else statements, loops, access, create, read, write, choose files or close files, variable assignments. Functions are very, very simple once we get into it, but right now I'm just going to tell you what the types are. Mathematical is kind of self-explanatory. You've got an if then else statements. If something is blue, then something else is green. Or, it doesn't really make any sense, but, if you got 2 cans, then throw them away. If you have 5 cans, then throw them away. If you have 3 cans, then throw them away. You can do it in so many different ways with if-then statements. If this is true, then this will happen. Else is basically, if this is true, then this will happen. But if it is not, then the else statement will execute. So if you have 5 cans, then throw them away. Well, I don't. I only have 1 can. So the else statement is keep it until you get 5 cans. Very simple. I mean, I don't know if I explained that quite well, but yeah, that's basically it. Loops are basically something that are used for multiple different things. Loops are something in which executes a set of statements or an event, or basically it's repetition. That's all you really need to know about it, is repetition. If you need to perform something more than once, use loops. Access, create, read, write, and close files, that's basically a process all together in one. It does have inputs and outputs. Reading a file is an input, writing a file is an output, but processes are basically accessing and closing the files. Creating and reading and writing are inputs and outputs. But it's within the process. And then you got variable assignments. Pretty much if you want to, assign a variable like pi, for instance, you can assign it 3.1416. And that's still considered a process. Now, for performing calculations, you got arithmetic operators. You got addition, which is the plus sign, subtraction, which is the minus sign. You got multiplication, which is the asterisk, and that's due to, not being able to use x, because x may mean something else somewhere else. You got division, and then you got modulus, which gives the remainder of division, and then you got an exponent. The reason why I would want modular is because if you're dividing a number, then it will give you the integer of that number. Basically, if you do 9 divided by 3, it equals 3. Well, if you do 10 divided by 3, it will still give you 3. But with modulus, it gives you the remainder. So that way you can conclude 10 divided by 3 is 3.33 repeating. And for relational operators, you got less than, which, an example, you got 18 is less than 34, which is true. You got less than or equal to. 34 is less than or equal to 34. Is that true? Yes, because that equal to is there. 18 is less than or equal to 34. Yes, because 18 is less than 34. So both statements are true. You got greater than. 20 is greater than 10. Well, yeah. And then you got greater than or equal to. Is 20 greater than or equal to 20? Yes, so that statement is true. Is 50 greater than or equal to 20? Yes, because that statement is true. It's 50 is greater than 20. You've got equal to, and the reason why we want to use double equal signs because some languages require you to do double equal signs to basically relate these two together. And that's the whole purpose on why it's called relational operators. What is the relation between 18 and 34? Well, 18 is less than 34. What is the relation between 20 and 10? Well, 20 is greater than 10. What is the relation between 5 and 5? Well, it's easy. 5 equals 5. That's the relational operator between there. And then you've got not equal to, which is represented with an exclamation point and an equal sign afterwards. The exclamation point is the not. So 5 is not equal to 2. That statement is true because 5 is not equal to 2. You got logic operators, which basically is and, or, and not statements. And statement, if C equals C and 25 is less than 50, then this statement is true. If C equals C, which is true, and 25 is less than 50, which is also true because 25 is less than 50. It's true. So if both of these are true, true and true, then this statement is true. If one of them is false, if C equals D and 25 is less than 50, this one's true, but this one's false. You have to have them both false. If this and this is true, then this statement is true. Now, what if you wanted to have an operator to where one of them is true? If either one of them is true, then a series of statements will execute. You use or. Or, if C is greater than C, which is false, because C equals C, it is not greater than C. Or 25 is less than 50, which is true, because 25 is less than 50. Then this statement is true, because of this or statement. False or true. Doesn't matter, either or. And that's very simple. What you would want to use these for is if you want to do within a range between 10 and 20, you would say that this number is greater than 10 and less than 20. That statement will be true. Now, if you was to have this number, this or statement, if you want something outside of a range, I want it to be outside of 10 and I want it to be outside of 20, outside of that range. So if you got your number less than 10 or your number greater than 20, then the statement will be true. You cannot put an and in there because there is no number that is both less than 10 and greater than 20. And the last logic operator is not false. Basically toggles between a statement to be true or false. Very simple. Now we're going to discuss output. Output's very simple. Data generated by the computer to perform a task. Displaying a message on the screen, for example, or to perform an action in a video game. And I've gave a pretty good explanation on the mouse too. The mouse takes the information that you move the mouse from your hand and it displays it on the screen. Same thing with displaying a message. You type something in on a keyboard, it'll display it on a screen. If you was to punch somebody on a video game and you right click for that, then every time you right click, the output would actually be somebody punching somebody in the game. And that's what an output is. And that's the end of this slideshow right here, and we're going to go in our next episode or tutorial, and we're going to start typing this stuff in to actually show you what all this means. Thank you very much for watching, and please stick with me for the next episode.